Oh man, sorry about that. Bienvenidos, mis amigos. We are going to work on classifying ourselves some triangles today. If I can get myself in a little more of a out of the way place. So today's goal is classifying triangles by their side lengths and angle measures. Today's probably be one of the only days we'll be doing a lot of measuring. Moving forward, I think you'll have a lot of the measurements provided for you, and it's going to be more problem solving and logic type stuff once you know the measurements. But today we're really going to dig in and find out about all these different triangles, and some of them can and will overlap. Equilaterals are isosceles. Isosceles can be equilaterals. Scalenes can't be equilateral or isosceles, but they can be obtuse, acute, or right. Obtuse triangles can't be acute triangles, and obtuse triangles can't be right triangles, and right triangles can't be acute triangles. You got all that? Also, equilaterals and isosceles can both be acute, and isosceles can also be obtuse. How about we do instead of talk, and we'll see it in practice here, okay? You can classify triangles by the lengths of their sides. In ABC, all the sides are of equal length. It is an equilateral triangle. Equa means equal, lateral means side. Equilateral triangle, okay? So in triangle AB equals BC equals AC, all the sides are equal. And in geometry terms, a lot of times if you see these little marks, or when you see these little marks, anything with the same mark has the same length. So everything with one hash mark is the same length, okay? Let's pretend this triangle is a different triangle over here, and it's got two hash marks and one. That means AC and AB are equal, but CB is different. So this would be an isosceles. That word, I'm a good speller, but that one always gets me. See? Ha! I forgot the S. Okay, but those hash marks, anything with the same number of hash marks is the same size. We'll hopefully see that in practice here a little bit. In triangle DEF, two sides are the same length, and it's an isosceles triangle. Okay, you can mark those like this. A lot of times, you'll see that that's marked a different length, or if they have to mark another set of equal sides, then they'll mark up with two hash marks. But in this case, maybe since there's just three sides, you don't need to mark that because we know it's not equal to those. Confused yet? I think it made that worse. My apologies. Okay, in this case, all three sides are different, so that's a scalene. So equilateral, three sides the same. Oh, you know what? I don't like this definition. Two or more sides in an isosceles. So technically, yes, an equilateral triangle is an isosceles, just like squares are rectangles and rhombus and parallelograms and blah, 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 and all that. I don't know how much this book uses that, but that's definitely the case. I think. I'm pretty sure. All right, so here's a scalene triangle. So isosceles, scalene, equilateral, all based on side length. Okay, no equal sides, two equal sides, three equal sides. Okay. Oh, I'm going to pause this while I adjust my ruler tool. Theoretically, you guys should have a hardcover book to do this. If not, you could pause me now. Otherwise, I'm going to get my ruler set to the right size and we'll just go through this together. Okay. Give me a second so I can get my ruler adjusted. All right, cut me a little slack while I stumble through this. Oh, and I did that wrong. Hang on. Ha! I gotta shrink up my ruler a little bit. So this is the process I was going through, is getting my ruler sized correctly. Okay. Can you measure that line segment for me? What do you get for CB? Okay, good. Oh no, come on. What do you get for AB? That's close enough. Don't judge me. I have feelings too. Okay, you got that while I'm rotating here? And what do you get for AC? So, the first one we did was CB or BC. We got 3, we got a 2, and we got a 2. What do we have here? I'm going to spell it right this time. Excellent. Let's do the same for the one down below. Notice I check my book to make sure I'm not goofing it up. You know, obviously, if you were doing this on paper, I would have you, come on. That's interesting. I would have you using, a little more careful measuring, but in this case, this is good enough for us. But usually I'd want you guys to check. Oh, hang on. Checking your millimeters. Okay, we've got a 3. I love how this tool here gives me the degrees, and yeah, I'm cheating because I know what it is. We've got a 3. Just go with me here. No, you stay there. And how am I doing on time? Not awful, but I'm not setting any records. And we've got 3. Now, I'm sure some of you sitting there going, I can see it's an equilateral triangle. No, you couldn't. You need to confirm the measurements. What this book is going to do, and I think it did in the last chapter, is it'll give you triangles that are like distorted, like the angles they write down aren't really the angles that are there because they don't want you to measure or eyeball. They want you to use the math and solve the puzzles. Okay, so 3, 3, 3, we've got a equilateral. Sorry, I was already thinking ahead to my next slide where I've got the wrong ruler. So what I'm going to do is copy that little fella, come here, get rid of this beast, do a paste. Oh, for crying out loud. That's what I did. Now my ruler's not big enough. Don't judge. I could still figure it out, though, because I'm going to go 1, 2, 3, 4, make a mark. 5, 6. Don't act like you're not impressed. Okay, got 6 for HI. I'm sure you guys... This one's a little easier to see. GH, I'm going to come in. My book says 2, so we'll say 2. And just for the sake of it, when I do GI, I think it's going to give me 4, I think. So if I have 2, 6, and 4, 3 different sides, what kind of triangle do I have? Oh man, my ruler is out of whack for this one. That's because when I copy and paste, if I don't have anything scaled correctly, then it's wonky. So what I should have done... Here's my 4. That's better. Oh, McCarthy. You crazy nut. And then my... Ignore that. Wait. Look at that. My 4 should have been right there. I can bring this over. What? Well, whatever. It's close enough. The book says 254. Oh, 254. That makes more sense. Okay. That's fine. We'll take 254 there. And a scaling. Really getting bogged down in these. Boy, okay. Who's that? Exit full screen. Let's get back in business here. See if we can wrap this dog and pony show up. Okay. Identifying right, obtuse, and acute triangles. You can classify triangles by the measures of their angles. And PQR are as a right angle. So PQR is a right triangle because it has a right angle. Okay. To make something a right triangle, it has one right angle. See how simple that is? This one here is a right triangle that is also isosceles because it's got the right angle and 2 equal sides. Here's a hint. If the sides are equal, then the opposite angles are equal. That might not be something we do yet, but if CB and AC are equal, then their opposite angles are equal. Okay? So that's a right and an isosceles. And then finally, if you have something with an angle greater than 90 degrees, it's just obtuse. If all 3 are less than 90, it's an acute. Okay? Right has one right angle, obtuse has one obtuse angle, acute has all acute angles. Okay? You can watch these. I'm not gonna, but you can. Well, maybe you can't. Maybe that'll be fixed by the time you get here. Who knows? Okay. Which of these triangles is right, obtuse, or acute? Oh, man, let's get my angle. So, I need to be... Can I lock that thing in place? No. Okay, so I'm going to just cheat and check here. Okay. See if I can get as close as possible with this. So this angle here, of course, if I don't have my protractor lined up. So if I do that one accurately, and again, just bear with me here, it's going to be 60. And then if I do, wait, is that the right one? P. Oh, P is not 60. Wait. Maybe P is 60. And I'm getting it goofed up. Sorry. So that's angle R. I want angle P. Angle P. I might have distorted this. I got 65 for angle P. Well, if you have these in paper, I'm just going to show you because this technology is not working. The book says P should be 65 because I know you guys know how to measure. This should be 55 and this should be 65. Oh, I was right on that. Okay, so my measure of P is 65. I had that okay. Measure of R was 55. No, R is also 65, and then Q is going to be the 55. Oh my gosh, McCarthy. Clean up your mess. There you go, that's 55. Okay, this actually does work. This is an acute triangle. See how they don't give it away with the vocabulary or with the article there? That's pretty impressive. Some book writers aren't that clever. Okay, this one here, do the same thing. And just because I want to find out right away, I'm going to go right to angle S because I have a suspicion that it's a right angle. And yeah, it's a right angle. So measure of angle S is 90 degrees. If I measured T and U, I'm let's say in both are 45. Honestly, if I'm just trying to find out it's a right triangle, I might not need to do all that. Okay, so STU is a right triangle. Okay. And then two sides are equal, so it's also isosceles. Finally, I'm going to get in under 15 minutes here, but it's going to be dicey. Interesting. They're having you do it by the angles on this, even though you can kind of see. So they're telling me angle Z is 20. I agree with that. 20. The nice thing is if you get your protractor and the student computer lined up, you can usually... Okay, what does it say? And this is 25. Yeah, it says that's Y is 25. And at this point, if I've got that, I might even say 180 minus 45 is 135. But just to double check. Like this. Kind of clumsy, isn't it? Technology, is all it's cracked up to be. Close enough to 135 for me to stop and move on so you guys can work. Okay? Ignore this. That should be deleted. It might not be on your slides anymore. Classify each triangle as equilateral, isosceles, or scalene, and then also classify it as right, obtuse, or acute. Okay? I'm not going to go and measure these. Hopefully you have a book to do this. If not, hopefully your teacher guides you through it. But in class, they should hand out a book. Otherwise, yeah, I don't have the angle measurements. Okay, so, okay, so let's see, ABC. If you measure out ABC, we find out is a scalene. And we also find out it's obtuse. Oh, and it's obtuse, ABC, because this angle's obtuse. Okay, if we do DEF, this guy here is going to be an equilateral. The book doesn't want you saying isosceles, even though it is. Bleh. And it's also going to be an acute triangle because all angles are less than 90 degrees. DEF. GHI is going to be an isosceles. That's equal. So GHI, and it's also going to be in the acute category. Okay. JKL is scalene and also obtuse. And then the right triangle. Wait, PQR has got to be something. No, yeah, PQR is the right triangle. PQR and nothing else. All right, my head hurts. You got all that? Just under 15 minutes, I'm going to call it. Sorry about the tech troubles, but yeah, we'll do better tomorrow. Bye, friends.